Let's start today with week 7. So we have completed 6 weeks till now. So we have crossed the 50% marks and we are on the other side of the course. Last 6 weeks of the course are remaining, and as Ria has requested or suggested that we may take up week 13 also to revise all important points of the course, right? So let us begin with this week's content and previous runs assignment solving. So, since it is already 7 o'clock, what we'll do is we'll revise the content which is covered in this week, and slowly we'll move on to 10 questions from last year's assignment. Okay, so this is the what we can say the important or the most important diagram in our course, which is types of learning analytics and how they are nested or connected with each other. So we have seen descriptive analytics, which answers what question, what our data looks like. And then now we are at the diagnostic analytics, which helps us find the answers to why questions, why certain things are happening in our classroom. So last week we have seen pattern mining and process mining both, and before that we have seen clustering and correlation both. But this week we'll be looking at clustering little bit in detail. We had seen clustering from scatterplot point of view, where we point the dependent and independent variable and we try to establish if there is any correlation between them. And now going one step further in clustering, what we try to find out is if we can make their groups, different groups. So this is one cluster, for example. This is another cluster, this is another cluster, and this is another cluster. Right, so why clustering is important, or why it is why we are supposed to look at it in detail, the answer lies in the fact that it helps in creating groups which are closely related. So, in order to do some prescriptive activity on our classroom, or in order to create some profiles for students in an online learning environment, it is important that we understand how closely our students are connected and how many user profiles we need to create, or how many personas for our students we need to create. So all these things are important and they help us in making our actions more personalized, so that our learning environment can be optimized, or learning experience can be improved. Yeah, so you all remember goal of the learning analytics, goal of entire learning analytics is to optimize our learning environment, to improve the learning experience of our learners. So in order to begin that, we have to create some student profiles. Some n types of students are there which exhibit the qualities which are closely related to each other, and so on. So this clustering is one step towards that, which will help us in predictive analytics also, and which will help us in optimizing the learning environment for when we want to do some personalization in our computer based learning environment, right? So yeah, moving on to these types of clustering, like k-means clustering and hierarchical clustering in detail. um, so we'll start with k-means clustering. So as the name suggests, k is the number of clusters. Yeah. And means is, so every cluster will have some center point, right? So if this is our data points, yeah, and this is our cluster center 1, let's denote it by C2, and this is cluster center 2. So how do we compute these cluster centers of C1 and C2 of these two clusters is by computing mean of the data points which belong to that particular cluster. Yeah, so that is K means clustering. Number of clusters is denoted by K, and we compute mean or average of all the data points from that cluster and compute centroid of a particular cluster. So centroid is the word for center of that cluster, the pivot point from which the distance of every data point is computed. So that is referred to as centroid. Yeah? So hence it is written here that it is centroid based. And it is iterative approach. So we will compute the distance from centroid to each data point. So we'll compute that iteratively to have the points which are located closest to the centroid in same cluster. So we will compute distance of every data point in cluster C1 from centroid C1 also and from centroid C2 also. Yeah? And these distance could be calculated by using either Euclidean distance or Manhattan distance. Yeah. So Euclidean distance is x minus y, x minus y square, sorry, not x minus y, x1 minus y, x1 minus x2 square plus y1 y1 minus y2 square root is the Euclidean distance, while Manhattan distance is computed as like distance between the Manhattan city is pursued as a grid. So how do we calculate distance between grid? Is this point plus this point, so distance between these is x plus y, something like that. Okay, so we need to decide which formula we are using to calculate the distance beforehand and use that same formula to compute the distance between the centroid and the data points. So this is called squared error, where we remove this square root sign and consider difference between the data points and square it. Difference between the data points from the centroid, from each centroid. So the centroid is the center of the group of the data points. So when we will get the optimum centroid is when that distance will be minimum. So we are considering squared error here, and this j function, this is called j function. Yeah? So this has to be minimum, close to 0, or at optimum level, where if you increase the number of centroids, then it should not affect your this error function or squared error, right? It is also called objective function. This I have denoted, or this graph I have taken from Sir's video, where he has explained that how to decide which what number of how many clusters should be formed with our data set. So we computed distance between the centroid and data points. Each of the centroid and data point, we add them together and we repeat that for all the centroids we are considering. If we are considering 2 centroids, then from C1 and C2 we will compute distance, the squared distance, difference between the coordinates, and we'll square that. So that squared distance we compute for every data point from every centroid and we add it. So that will give us j, or objective function, or squared error. So our objective for k-means clustering is to have come to this elbow. So please look at this graph. Let me zoom in. So now on y-axis there is j function or sum of squared error. And on y function, on x-axis there is number of clusters. So for n or a cluster, only one cluster, then only one centroid, and the distance from each data point to centroid, we will compute the difference and square it. So it will be here. Yeah, somewhere here, this point is here. And we do that, we increase the number of centroid and we compute j for every number of centroid, like 2 centroids, 3 centroids, 4 centroids, 5 centroids, and so on. So now what happened, you will notice that after 3, after n or number of clusters is equal to 3, this point, the difference between the error function or the j, the value of j, is not much. But here the value differs very significantly till j is equal to 3, right? But after that, this value does not differ very significantly. There is a minute difference, but not large difference like here, some 50 plus or 55, and then here is 25. So the difference between number of clusters is 3 and number of clusters is 4. The difference between the j value is not much. So wherever the elbow happens, so this is known as elbow. Yeah, so wherever the elbow happens in that, when we plot the j values versus the number of clusters, so whenever the elbow happens, that is the optimum number of clusters for our consideration. Yeah, that is how we determine how many numbers we should do it. Okay, so Ria's question is regarding which one we should use. You mean to say distance formula, Euclidean distance or Manhattan distance? Yeah, so mostly in the problems it will be specified whether you should consider Euclidean distance or Manhattan distance, but Euclidean distance is more common, yeah, compared to Manhattan distance. So mostly Euclidean distance is given. Yeah, it is this formula is used to compute the distance. This I'm just giving you for information that there are multiple ways to calculate distance, but Euclidean distance is more popular. Now going to hierarchical clustering is there are two approaches of hierarchical clustering. So now we saw that k-means clustering is combining nearest data points or closest data points together to form a one cluster. But what happens when our data is spread across and you want to kind of form clusters there? So what we can do is we can have two approaches. Either we can go each data point we consider as an individual cluster, and then we compute distance between the cluster and we combine two clusters. So this is A and this is B. These are two different clusters. Then we this is C. The distance between, and let's consider D also. So distance between A and B is very less, so we combine them together to form one cluster. Now this combined cluster is closest to C, so we combine it with C, and now we combine it with D and then one cluster. Yeah, so this is bottoms up approach. We are building the tree, and when we are reaching the root, that one cluster which will have all the clusters together will stop there. So this is the bottoms up approach, is Agnes or agglomerative nesting. And divisive analysis is exactly opposite of that. As the name suggests, we have it is dividing. So all the data points are considered as one cluster, and then we combine, we go from top to bottom. We say that this particular data point is farthest, so we separate it. So there are A, B, C, one cluster, and D, because this particular point is D and it is farthest. So we divide it, and then we follow top down approach for Diana or decisive analysis. Yeah. So this is AB and this is C. Now at the bottom there is A and B. So this is top down approach, and Agnes was bottoms up approach. So theory of this clustering is very easy. The computing is also very easy. So I'm hoping that we will be doing this Okay, single linkage and average linkage, and so we will take this up. Single linkage and average linkage is nothing but how we are linking these. So elbow method, Shrija, let me first take up Shrija's thing. Elbow method, there is one problem on elbow method, so I'll repeat the whole thing there, so this will be covered. Now coming to Ria's question, Ria is asking what is single linkage and average linkage and how to calculate. So single linkage is where we compute the distance between these. Hierarchical clustering is where we compute the distance and we try to combine the closest or nearest two data points in Agnes method when we do the bottoms up. So in bottoms up approach, what happens is every data point is one single cluster, and then we compute distance between the cluster, just like in k-means we compute distance between centroid. So here each data point is cluster, so their centroid is data point itself, right? The centroid is data point itself. So now what happens is we compute the distance between two clusters. So here A and B are two data points or two clusters, so we will compute their distance and we'll combine them. So what happens is we come to this point or new centroid, right? So this new centroid would be average of these two data points A and B, so that's the average linkage. And single linkages, so single linkage happens here, every data point is separated, singular thing. Yeah, so mostly you will be asked to follow the average linkage only because that's easy to do, bottoms up approach. So same thing we follow in k-means. So when k-means ka problem comes, you will understand how do we calculate this average linkage. It's nothing but averaging these data points. Okay, so these two are two separate data points, right? A, B, and what happens is they are the clusters also. So if they are individual data points are individual clusters, then their center or centroid will be that data point itself, right? So we are combining these two because distance between A and B is far less than distance between any of these other centroids. So we want to combine these two centroids to create another bigger cluster. So what will happen is how we will link these data points. Here, can you see the link? Yeah. So how we will link these data points and how we can come up with this new center is by averaging this data points A and B. So A and B average will be this new centroid. So that is average linkage. So using an example, we are going to do that. That's what I was telling you, that once we go to the example, it will be clear. It is very easy to do. Don't worry, you will get it, you will understand it. Okay, so both things, the elbow method, the J elbow, what is the how to determine k number of clusters, and this also, it is easy to understand. Okay, so we saw the hierarchical clustering. So it is also represented pictorially, every data point. So we saw here how the tree goes. Okay, so this tree in a better way is represented as a dendrogram. Yeah, this tree structure is called as dendrogram. Okay, so now in this particular question, the asked question is, in this given dendrogram, how many clusters will be obtained if we choose the line across 0.6? So here this is our threshold. So at this point, the number of clusters will be considered as our final number of clusters. So this is the question, that at this particular point, how many clusters are getting formed. So in this diagram, what I've showed you that these two data points are separate and then we are combining them into one single cluster here, right? Let me change the text color here. Yeah. So this is one cluster C1, this is another cluster C2, another cluster C3. So C2 is equal to point C and C3 is equal to point D. So now what happens is we are combining this C1 and C2 over here. So one bigger cluster is here. So at this particular point, there are 1, 2, 3, 4 clusters. But if we consider this as a threshold, so there is C1, there is C2 and C3, right? There is C1, C2 and C3. So there are 3 clusters. Here there are 4 clusters. And then we are combining this C1 and C2 into C4 over here, and this remains C3 only. So now finally we are combining this C3 and C4 into C5, which is the biggest cluster, which includes all the data points. So if there is a threshold value at this point, then we have two clusters, right? So we will follow the same technique here. So at this point, this is one cluster, two cluster, three clusters, and four clusters, right? The point where the number of intersection points we are computing. Here total are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 clusters at this point. Then at this point, 1, 2, 3, 4, 5, 6, 7, 8, 9 clusters, because we have combined this 2 and 10 into one cluster, so it becomes 9 clusters. So now we consider this point. So here this is one cluster, this is one cluster, combination of 5 and 8 together. 9 is a single point cluster, then 1 is single point, 4 is single point, this is 3 single point, and 6 and 7 combined together. So 1, 2, 3, 4, 5, 6, 7 clusters. Here at this point, 1, 2, 3, 4, and 5 clusters. And now these two clusters are getting merged into one. So at point 6 it becomes one cluster, two clusters, 3 and 4. So our answer is number of clusters are 4. So it is very easy. We just have to understand where the intersection is happening. That point will be the cluster. So how many clusters are here? There are 4 clusters. So now can you tell me at this point 7, how many clusters are there? Yeah, very nice. I'm getting correct answers in the chat box. 1, 2 and 3, because these two clusters are combined into one cluster here, so it becomes 3 clusters. Okay, so if such questions come, such question comes, you just have to do it this way. Okay, very easy to do. So now this is the elbow curve, the doubt which I think Shrija had asked. Yeah, repeat the elbow method. So why do we compute this? This is called sum of squared distances, or J value, and this is number of clusters, or K value. Okay, so you have to understand that we have to determine, or we have to choose the number of K before we start computing the distance from the centroids. So how to ensure that our number of clusters are optimum? They are not too less and there are not too many. If there are too many clusters, then the whole point of combining the closest into one group gets negated. Every data point could be a single cluster. So why are we even combining nearest clusters? Is when we have thousands of students data, then we want to do some profiling and create some common profiles which exhibit some common characteristics, which combine common features of every students, and then create similar students are combined to create one persona. Yeah, so that's the whole purpose of creating different clusters. So how can we plot this graph? Is we have to decide how many centroids we will be considering, and using the formula which I had given, the distance between summation of all distance, so this J formula, you have to calculate, yeah, distance between the centroid and the data points, square it using this formula. Okay, so this formula becomes x1 minus c1 square plus c1 x1, yeah, the x coordinate of the centroid, and y1 minus cy1 squared. Yeah, you have to sum it for all the centroids. So if there are 3 centroids, then and 5 data points, then all 5 data points from that particular center we will combine them, we'll calculate and we'll add them. Yeah, so there are centroids, no, sorry, 3 centroids, C1, C2 and C3, and 5 data points, A1, A2, A3 and A4 and A5. So how can we compute J is, we will compute distance of every data points from centroid C1, and we'll compute this squared distance between, squared error. So I am not going to solve this week's assignment problem. We have one problem based on the similar thing. At that time, we will understand how to calculate this. But since there is deadline of this assignment is still not over yet, so it will not be ethical for us to solve this week's assignment problem in this live session. So we will not do it. But if you are still confused, we can take this up in our final revision class. Okay. So we will not be solving it, but we will be solving a similar problem. Okay, so you have to calculate distance between all the data points into centroid. Okay, and we will add it, we'll do it all the data points from C1 using this formula. There would be coordinates xy given for every centroid point, and we would be having data points xy coordinates. So we will use this method to add all the data points ka distance from C1, all the data points ka distance from C2 and all the data points ka distance from C3, and everything we will add. So it will give us J value for K is equal to 3, because there is 3 number of centroid. So likewise we can calculate from centroid number 3 to centroid number 5, 6, there is no limit to that, and we will plot it. So K will be on x-axis, K is number of centroid, and on y-axis there will be sum of squared distance. It is easy to compute. There is a problem below which we will be doing it. So right now, if you are not understanding the computations, we'll be doing it at that time, so you will understand. But if there is a graph given, then how to determine is, we have to see till which point this squared error, the sum of squared distances between the centroid and the data points, is reaching the elbow curve, reaching the curve. That means below that point, the difference between this squared distance or the error function is not much. It is not minimizing, it is not reaching to that limit to 0. So the most significant or the turning point is this, x is equal to 6. After that, the j function value is not getting impacted heavily, right? So this gives us answer as 6, because this will be the turning point or the elbow, the point, elbow point. Okay, so elbow point gives us the optimum value of k. So here elbow point is happening at 6, so our answer is 6. So choose the next question, choose the hierarchical clustering method from the given options below. So this is based on the theory which we are covering. Okay, so I have given you one hack of for understanding whether the question has multiple is multiple choice or is a single choice, like multiple correct answer, MSQ, multiple select, or out of multiple choice we have to select one. So what happens is, so what happens is, when there is single choice, all your options will have the radio button or circular button in front of it. Okay, and if there are multiple options are correct, then what will happen is, it will have a square button or select button in front of it. Okay, so this is one hack which I am telling you. So if you see such marks before the options, then you have to understand. So this is multiple choice, so there are more than one options correct. So hierarchical clustering methods are, I'm getting all correct answers in the chat box also. Okay, so hierarchical methods are agglomerative nesting and divisive analysis, option 1 and 3. There is no explanation as such for this. Right, let it be. Okay. What are or is true about Agnes method of clustering? Okay. So Agnes is top-down approach. Each data point is considered as an individual cluster at the beginning of first iteration. All the data points are considered as a single cluster in the beginning of first iteration, and bottom up approach. Okay, so there are two methods, Agnes methods and divisive method. So divisive is you start dividing the data, and Agnes is you build up the tree, right? So Agnes is bottom up approach, and each data point is considered as individual cluster at the beginning of first iteration, then the nearest two are combined together in the next iteration, and so on. Okay, so option 2 is also correct and option 4 is also correct. Both the answers are correct for this. Yeah. So option 1 and 3 are true about divisive analysis, that all the data points are considered as a single cluster in the beginning, and then we divide it, we keep on dividing the data till we reach to the point that every data is part of a single cluster, every data is a cluster in itself. So that's the stopping point for divisive analysis. And for Agnes analysis, we combine initially we consider every data point as individual cluster, and we go on combining them till all the data points are combined in one single cluster. So question 3 is theory based questions, that which of the following names are for hierarchical clustering. So hierarchical clustering types are agglomerative clustering and divisive analysis, or Diana method or Agnes method. Okay, so agglomerative is also known as Agnes method, and divisive is also known as Diana method. So coming to question 5, which is the calculation problem for our practice. So we'll read the question carefully first. Sonia is teacher in private school teaching mathematics and science to the student of class 2, and there are 5 students in her class. She assessed the performance of the students on 5-point Likert scale for both the courses, and she wanted to group the students into 2 groups. So 2 groups. What will be the value of k for 2 groups? Yeah. Since number of groups is 2, so absolutely right, the k value will be 2. Then adapt different teaching methods between them. Now to identify groups, she used k-means clustering technique for 2 iterations. The distribution of Likert score of the students in both the courses, and the initial centroids. So initial centroids are C1 and C2, which are given. So we don't have to worry about that thing. Okay, initial centroid is assumed by the teacher are shown in the given figure. Then 5 data points and their value is also given. These are the 5 data points, A1, A2, A3, A4 and A5, and these are the 2 centroid values, right? So everything is given to us, and what we are supposed to do is we are supposed to apply the procedure of k-means clustering up to 2 iterations, and calculation should be made up to 2 decimal points, and distance formula is also given. The Euclidean distance square is also given. We have to consider x2 minus x1 square and y2 minus y1 square. Okay, so everything is given. Centroid is given. Both the centroid points are given, initial centroid, and all the data points are also given, right? So now we are supposed to ask what will be the new centroid after first iteration. Okay, so what we will do is we will compute yeah, so let me just so let's write all the data points here. A1, A2, A3, A4 and A5. What's the value of A1? 2, 5. A2 is 5, 3. we'll do a tabular calculation, yeah, so that we don't make any mistakes, because these are kind of repetitive calculations. So we may end up making some calculation mistakes. So that's why I have this habit of making a table first. And now we will compute the distance, okay? Distance from C1 and distance from C2 in two separate columns, okay? So what are the C1 and C2? 4, 2 and 3, 5. 4, 2 and 3, 5, okay? So our distance formula was x2 minus x1 square plus y2 minus y1 square. Okay. So now what we will do is we will compute the distance between the centroid one from each point. Okay. So difference between this and this. So 2 minus 4, since it is square, so which coordinate which we are subtracting from which coordinate doesn't matter. Simply difference between these two numbers, the two coordinates, x coordinates and y coordinates, and we have to square it. So even if it is negative, after squaring it will become positive, so it doesn't matter the sequence which you are considering, which two numbers, the order in which you are subtracting, that's not important. So difference between 4 and 2 is 2, so 2 square plus difference between y coordinate 3 square, right? So similarly we will compute for a2, a3, a4 and a5. So 1 square plus 1 square, 1 square plus 2 minus 1, 1 square, 1 minus 4, 3 square plus 5 minus 2, 3 square, right? Is it correct? Yeah. 0 square plus 2 square. Yeah. So 4 plus 9, 13. Then yeah. 1 square plus 1 square is 2. 1 square plus 1 square 2. 9 plus 9, 18. And 0 plus 2 square is 4. Yeah. So now we will do same thing for centroid 2. So this is our first part of that formula, J formula, okay? So I'll show that formula for computing J value again. So here we have to, for all the centroids, so this is number of centroids. For all the data points, we have to compute their distance from the centroid and add them together. So this will be one part of the formula. Similarly, we have to do this for all the centroid. How many centroids we are having for this? 2 centroids. So we will do it for both the centroids. And then once we add their squared distance, we will get the value of j for n k is equal to 2. Okay. So going back to our calculations, we will sum this particular column, we'll sum this particular column, and when we add them, this will be j value for k is equal to 2 for our this data set. Okay, so now you got how to compute j value or summed square or the error function. Whatever the question is, this is the method you have to follow. If you are asked to compute j value or what is the sum of square, the error function, the distance between the centroid and the data points, their square, so this is how you will do it, whatever may be the question. Okay. So now coming to distance from C2 of all the 5 data points. So here 1 square plus 0, then 2 square plus 2 square, 0 plus 4 square, then 2 square plus 0, then 1 square plus 1 square, 1, 8, then 16, 4 and 2, right? So now we have to kind of see which data point will belong to which centroid. ठीक है. So we have to say out of these two distances which is less. This one is less, so that means A1 will belong to C2 or cluster 2. The centroid will be C2. Now out of 2 and 8, which is the smaller? This is smaller, so A2 will be part of cluster 1 or C1. So between 2 and 6, 2 is smaller, this will belong to C1. So now you tell me, A4 will belong to which cluster, C1 or C2? C2, absolutely right, because out of 18 and 4, 4 is lesser, so that data point A4 is closer to C2. That centroid is nearer to A4, so it will belong to C2. Now 4 and 2, 2 is smaller, so A5 will belong to C2. Okay, so now we know that point A1 and point A4 and point A5 belong to C2. So what we will do is we will average them. Yeah? So average connection, we will average them. So x coordinate is, so new C2. After one iteration, what is the next centroid that we are computing? So we are averaging all the points which belong to C2. So let's do this for C1 first, because C1 has just two data points, right? C1 has A2 and A3. So A3 x coordinate is 5 plus 3 divided by 2, and y coordinate is 3 plus 1 divided by 2, which will give us 8 divided by 2, 4, and 4 divided by 2, 2. So this will be, after first iteration, this will be our centroid. So this will be C1. Okay, so now coming to C2, we have to average the 3 points. Okay, oh shit, mama, there is no undo button here. Shit. Let me try the undo. No, we have to do it again. Oh, nice. So you guys have the answers with you, right? So quickly, I'll try to write it again. A5, A1 was A1 was 2, 5, A2 was 5, 3, A3 was 3, 1, A4 was 1, 5, 5, and A5 is 4, 4. C1 is 4, 2, and C2 is 3, 5. Okay, so this is 2 square plus 3 square, right? 13. This is 1 square plus 1 square, 2. 1 square plus 1 square, 2. 3 square plus 3 square, 18. 0 plus 2 square is 4. And let me quickly do this. 1 square plus 0, 1. And 2 square plus 2 square, 4, no, 8, sorry, yeah. 8. 0 plus 4 square, 16. 2 square plus 0, 4. And 1 square plus 1 square, 2. So yeah, yeah, this will belong to C2, C1, C1, C2 and C2. So we were computing new centroid. New centroid C1 is A2, A3, which we will average out. A2, A3, 5 plus 3 divided by 2. We are computing mean of x coordinates and y coordinates, right? And 3 plus 1 divided by 2, which are 8 by 2, 4 and comma 2. Yeah? So this is new centroid C1. Now we have to calculate C2. C2 has A1, A4 and A5. So we will average the x coordinates first. Okay, so 2 plus 1 plus 4 divided by 3 and 5 plus 5 plus 4 divided by 3, right? So 7 by 3 and 14 by 3. 7 by 3 is 2.33. Yeah. Comma 14 by 3 is 4, 2. 2 is 6, 7. Yeah, 4.67. 666. So rounding up to 6, 7. Yeah. So this is the answer. So these are the new centroids C1 and new centroid C2. And this here we followed the average linkage. Yeah. So I hope Riya this is easy and easy to follow for you also, and you got the answer correct. Yeah, you got the answer correct, right? So that's the, so you got which option is correct. I think the correct answer is option 2. Yeah? 4 comma 2 and 2.33 comma 4.67. Yeah, option 2. ठीक है. Which are the data points clustered with centroid C1 after first iteration? C1, A2 and A3. We already found it. A2 and A3. Yeah. So both the data points belong to cluster 1. And we got new clusters also. So now we are supposed to do we are supposed to find new centroids after second iteration. Yeah. So here the place is more, so let's compute it here. Yeah. C2, and we will do A1, A2, A3, A4 and A5. So now A1 are 2 comma 5, 5 comma 3, 3 comma 1, 1 comma 5, 3 comma 1, 1 comma 5 and 4 comma 4. That's right. And now new centroids. Now we have to consider new centroids. Okay, so new centroid C1 is 4 comma 2 and C2 is 2.33 comma 4.67. So now simply easy. Okay, Ria, we will see for everybody's benefit. I will also do the calculations and we will see if the centroid remain the same, if it is given the same clusters. Okay, so let's calculate the distance. So 4 minus 2, 2 square plus 3 square. 1 square plus 1 square. 4 minus the 1 square plus 1 square. 3 square plus 3 square. 0 plus 2 square, which is 4 and 9, 13. 1 and 1, 2. 2. 9 and 9, 18. 4. So now these are the new centroids. So we need to compute the difference, like 0.33 square plus 0.33 square. Now let me do this, shift it here. Okay, so here the distance is 1.67 plus square plus 0.33. No, 1.6, not 0.33. I don't know where I was looking. Yeah, 1.67 square. So somebody can tell me what are the values to write here and here, okay? Because these are point square, so I will not be doing it orally. So here it will be 0.67 square plus 3.67 square, then 1.33 square plus 0.33 square. 4 is 2.33 is 1.66 square. 1.67, no, 671, yeah, 1.67 square plus 0.67 square. I think simple calculator is allowed in exam time for our benefit. The non-programmable scientific calculator is allowed for NPTEL exams. So don't worry, if such number comes, it will be easy to compute. Okay, so this is 0.33 square, we convert it to plus 0.33 square, which is 0.218, right? Okay, we will take up the doubt in the chat box a little later. Okay, then next point is 1.67 square plus 1.67 square, which is 5.5778, so we'll consider it as 58. Then next is 0.67 square plus 3.67 square, which is 13.9178, so we can consider 8. Okay, then 1.33 square plus 0.33 square, which is 1.878. Okay, now this is 1.67 square plus 0.67 square, which we have already done, I think. 3.2. Okay, yeah, so these are the answers which I am getting. I hope I have not made any calculation mistake there. Okay, so now let us compute which point belongs to which cluster. So this distance is less, so A1 will be belonging to C2. Now 2 and 3.5, this distance from C1 is less, so C1 13 and 2 13.99, almost 14. This distance is less, so C1 18 and 1.8. Of course C2 distance is less, so C2 4 and 3.2. Am I making any mistake here? No, C2, so this is less, so C2 only. Okay, it was a close call, but C2, yeah. So I think the distribution or this thing remains the same. It was earlier also, C1 had A2 and A3 and C2 had A1, A4, A5, so it remains the same. So if the points belong to that same cluster, then their average will also remain the same. Okay, so we need not do the calculations again. Whatever calculations we had gotten previously, that was 4,2, and what was the other coordinate? Yeah, 2.33, 4.67. 4.67. This is C1 and this is C2. Yeah, so it remains same. We are not doing the calculation because the point distribution is also same, so their average is going to remain the same. So this is the answer after second iteration also, which is I think option number 4. Yeah. So it is easy calculations, you just have to keep on repeating. Second row sum is yeah, let me check. 2.33, 2.67. Yes, you're right. 2.67. Yeah, you're right. 2.67 plus 1.67 square. So, what is the final answer? 2.67 square. Oh shit. 2.67 square plus. So, this 1.67 is correct, I think. No? 9.99. Yeah. 9.99. Let me correct this. 9.918. Yeah, but still there is no difference between our answer and this. It still belongs to C1. Yeah. It still the A2 point belongs to C1. So yeah, that even that after that calculation mistakes, I hope other calculations are correct. Let me cross check once. Yeah, 0.67 and yeah, 3.67, 1.33, and yes, others are correct. ठीक है. So after correcting this mistake also, we are getting same distribution of clusters, no? Because this is less than this, so again it belongs to cluster 1 or C1. So still these calculations are same and answer still remains option 4. No? Got lucky there. Now what are the data points clustered with C1? Again I think A2 and A3. Yeah, after this calculation also, yeah, C1 are A2 and A3. So answer is same. Now going to next question. Question 9. In k-means clustering, the value of error function is minimum. So this error function is nothing but j. This error function is nothing but j, or sum of the square of the distance. Okay, so it is the question is getting asked about error function, which is distance between data point and centroid square. Yeah, the distance between data point and centroid, and we have to square it for getting the error function. So now we know this thing about error function. Now can you tell me which option is correct? The data points are grouped in two clusters. At that time this value of error function or value of j will be minimum or close to 0. Okay, we have to consider that the value of j should be minimum or close to 0. Then option 1 says data points are grouped into two clusters. So we saw that previously it was two cluster model. There were two clusters, and this is the j which we have computed. This is j. So once we add this, it has points, so it will take a lot of time. Let's add this. Okay, so let's do this j. So 13 plus 4, 17 plus 18, 35, 39, and this is 9, 25, 29, 31. Yeah. So this thing is 70. So for j is equal to, for k is equal to 2, j value is 70. So is it close to 0? That 70, is it close to 0 when there are two? Not always, right? So we can't say this for sure that when we have two clusters the j value will always be minimum. This is, we can't say this for sure. Now similarly, when there would be more than two groups, or there are three groups, three clusters, then the distance between centroid and each of the data points, the difference, and then we will square it. So that will be minimum. When we add it together, will that be minimum? We are not sure. When all the data points are under one cluster, all the data points are under this one cluster C1. So this difference or the distance between all the data points and C1 and square it will definitely not close to 0. It will be maximum for one cluster, and similarly it will be going on decreasing when we increase the number of clusters. So we'll have to think about when this difference between the distances and the data point, the centroid and the data point, will be minimum. We have to think about that scenario. Okay, so now read the option 4 carefully. The number of clusters and the number of data points are equal. So what happens when each data point is a cluster in itself? What will be the centroid in that case? The data point itself, right? So if all the data points are considered individual cluster, like we saw in the beginning of agglomerative clustering, every data point was a cluster. So at that time, centroid was the data point itself. So what will be the difference between the centroid and the data point? In such cases, it will be 0 because they are one and the same. The data point itself is the centroid. So in that case, it will be 0 and it will be minimum, right? So option 4 is always correct. When the number of clusters and the number of data points are equal, or each data point is considered a separate cluster, at that time the error function will be minimum. So correct answer is option 4. Okay, going to last question for the day, which is needed by k-means clustering. So when we perform k-means clustering, which points we need to be pre-decided. So we saw one problem of k-means clustering. So, and we have discussed this also. So what all are the things which we need to consider beforehand, or which are absolutely needed or pre-decided for this thing. Okay. For this k-means clustering, we have to have definite distance metric. Which formula we are using to compute the distance? Yeah, either Euclidean distance formula or Manhattan distance formula, that we need to decide beforehand. Then we need to decide how many number of clusters we want to consider, which is denoted by k. And we also should have what are the initial centroid, what are the initial center points, because without centroid we can't compute the new centroid. Okay, I told you that it's an iterative process, so we have to guess first centroid for before the first iteration. How we will calculate the distance between centroid and the data points if we don't have centroid? So first initial guess we have to do for cluster centroids, and then we will do the average of the data points belonging to that centroid to compute new centroid. So initial, like, needed thing is initial guesses or the first clusters for centroid. Yeah, so this is also correct. So option 1, 2 and 3 are all needed when you want to go ahead with k-means clustering. Okay. Okay, so I'm getting a very interesting comment in the chat box. So comment is, but isn't it the case that too many clusters will lead to more errors in computation? Of course it will lead to more errors in computation. That's the whole point of coming up with a J curve, because that error function, it follows this pattern, this curve. Yeah, let's go back to that graph of J. Yeah, either this, it is like this, not increasing like this, but somewhat like this. So at this point we will see where the elbow is happening, and that is considered optimum number. So in k-means clustering we will be using this optimum value of k. So best value of k is equal to number of data points, but we are not going into putting every single data point into one single centroid, but we want to create some profiling of our data points. We want to combine couple of or more than one data points into one cluster, and then consider that cluster as one group of students. So that's where this j value or the error function comes into picture, and you have to kind of the optimum number of k is given by where the elbow happens in this graph. Okay, that's the whole point of, so the doubt which you have raised is very nice, that clears many things, that's the whole point of having this considering this k value, or how to come up with the optimum number of clusters to consider. Then there is next question, any data points we can also consider as centroid? Yes, we can consider. So there is no what you can say restriction onto which could be your initial centroid. Okay, because initial centroid will give us some idea about which points should be clubbed together. Hmm? Then the centroid role, that initial centroid, their role is over. As you saw in this particular problem, they were given two data points, no, the c1 and c2. So we can see, like visually we can see that a5 is closer to c1 also and c2 also, right? So when this averaging happens, so new average is somewhere here. So now and old this c1 remains the same, like this also changes but remains closer to 4,2. So what happens is, now this distance may be lesser than compared to this particular distance. So this point may shift from cluster 1 to cluster 2 in second iteration. Yeah, so here the role of initial gases of centroid is very limited. That doesn't matter your division of, or the cluster formation, yeah, the division of points where they are going into each cluster. So we can consider any point as initial centroid. That point could be one of the data points as well. So considering any point randomly, any point as initial centroid is also accepted while doing calculations for k-means clustering. Any more doubts? So there is no definite way of calculating k value. uh, I have already shown you how to compute this j value, so you do it. So now this was done for um, k is equal to 2. So similarly you can do for k is equal to 1, k is equal to 3, k is equal to 4, k is equal to 5. Randomly assume any centroid and keep on doing it, and check, plot it x against y, this error function, like this is the value of j 70. So similarly you can do it again and again for all the number of centroids which you are considering. So this particular table is for 2 centroids. So you can have, for one centroid you can have similar table, for 3 centroids you can have similar table, for 4 centroids you can have similar table, and at the end you can add this to get the j value. Once you have the j value and k value, then you can plot it and you can see where that elbow is happening. So that will give you optimum value of k. You remember that graph, okay, the point where after which the j value, the total j value, how it doesn't impact much. So that will give you optimum number of clusters or optimum number of k. So if you don't know what is the value of k, then you randomly consider as 2 clusters or 3 clusters. That depends on your requirement. So you remember this particular problem has that the teacher had to divide the students into 2 groups, so that the different teaching strategy could be deployed for 2 different groups. So here she decided that she wants to divide the students into 2 groups. So similarly you can decide the how to divide the students into 2 groups. Clustering algorithm, k-means or hierarchical. So all these decisions will be made on what is your data size, how your data is distributed. So that's why the first step of our learning analytics is doing descriptive analytics to understand what the data looks like. So once you have some idea about this data points, then you can decide. So in most of the cases, we like in this particular problem, the teacher wanted to divide the students into two groups depending on the teaching strategies or their requirement of the pedagogy. So similarly, when we know the k beforehand, then we can do the k means clustering. When we have number of clusters decided, pre-decided, then we can go with the k means clustering. And hierarchical clustering is more for, so what will happen in hierarchical clustering is the either it will reach to the root of the tree, or when each individual data point will be considered as separate cluster, it will keep on dividing. So at that time you have to see the threshold, in first problem. Yeah, the first question. Yeah, here. So you have to decide what is the number of n. So it again depends on what type of data you have, what is your requirement. Right? So nothing is better, everything depends on your requirement. Is there any further reading material on this? There is reading material will become more complicated. I'll advise you to go through the videos again, go it twice or thrice, go through the their what you can say, the PPTs which Ram sir is using for teaching. Go through that also, and if you're interested to know more about this topic, then I will suggest you can ask Google. You can look for the Google it, or search for the videos in YouTube onto particular topic which you are interested in. So there is, I don't know of any particular book focusing on clustering and all, but there are like different blog posts written, so sometimes they are very informative and good, so you can look over the internet for more deeper understanding on this topic. But I'm sorry, I don't have any idea about this suggestion that okay, for clustering read this article or read this book. I'm so sorry, won't be able to help you there. So I hope somebody had asked to repeat question 5. I hope this like this calculations explained. I did not do it again, but I explained in brief how to do it. So I hope that's correct. That's fine for those who wanted me to repeat question 5. We just have to compute this difference between these coordinates and square them and add it. That's how we do, and then we decide which is the this point is closer to which centroid. That's how we assign centroid to that particular data point. Who had asked? So Shrija, is this fine? Yes, sir. I'll keep this here so that you can assimilate this what I have done. So what I have done is I have difference in the coordinates and squared them and then added and gotten the distance, squared distance between this data point and the centroid. So wherever the squared distance is minimum, that particular data point gets assigned to that particular centroid. So here I have highlighted which is minimum and why it is getting assigned to which centroid. So if there are no more doubts, then we can close today's session here. So C1, C2 is nothing but average. We are averaging the data points, coordinates of the data points. It is very clearly mentioned here that A2 and A3 are the data points which belong to cluster 1 or C1. So how we will calculate the new centroid points is by averaging A1 and A2. So A1 is 5 comma 3 and a3 is 3 comma 1. So 5 and 3 average and 3 and 1 average, that gives us 4 comma 2. Similarly, c2 is a1 a4 a5, so we are averaging x coordinates and y coordinates. So this is the new centroids which we are getting. So we have to repeat the same process. So in our second iteration, this assignment of data points did not differ. So C1, again A2 and A3 belonged to C1. So A2 and A3 belonged to C1 and A1, A4, A5 belong to C2. So their average is going to remain the same. That's why this centroids also remained the same, because this point assignment is same. Centroid is not changing because the data points which belong to a particular cluster C1 or C2 are same. So their average also remains the same. Hence, the centroid in after second iteration are same. So this is where we are stopping. So that means this, we are sure that A2, A3 belong together and A1, A4, A5 can be clubbed together in different group. So we will not be doing third iteration. When the centroid, we are getting a same value in the consecutive iteration, so we are stopping. So we will be stopping for this particular data set, will be stopping after second iteration. So agglomerative and decisive clustering differences in this particular slide. It is all theory part. There is no explanation as such for this. Agglomerative is bottom up. It builds tree from individual data points. So you have to stop when you reach the root. That means you have to stop when there is only one cluster at the top. And then Diana or divisive analysis is top-down approach, where we are considering all the data points as one cluster and then we are devising it, as the name suggests, divisive. So we are dividing it into different clusters. The data points which are together, where there is distance is less, they are clubbed in one cluster. And here we are separating the data point which is farthest from all other data points, and then we go on doing it until we have each data point into one single cluster. So that's the difference between agglomerative and divisive analysis. Yeah, computational methods are very easy. You don't have to, there are very repetitive calculations in this. So you have to be very careful not to make simple errors or silly mistakes in the calculations. That's the only caution word which I can give you all. So actually, the whole point of having this course is not to make you an expert in all these machine learning techniques, but the whole point is for you to be able to understand the intricacies or the usage of all these techniques. So now you know that how to decide the optimum number of clusters or optimum number of k by looking at the graph, the j value where the elbow happens. So likewise, there is practical takeaways of from implementation point of view. Not the aim is not the learning objective is not so that you can do it individually for a huge data set. That's not the aim. The aim is that a tool will do it for you, even for huge data set, but you should be able to interpret the results. So when you give this clustering, your data set for clustering to online tools which are available, they give you results in these numbers, that this for this k this is the j, or squared error is this. So that you can interpret those numbers and decide the optimum solutions for your problem. Yeah? So practical usage is from that point of view, from application point of view, from usage point of view. So it is not expected that you sit with huge data set with pen and paper and do it yourself. That's not the aim is to, so that you are able to understand and interpret the results which you are getting from this automated websites or the online services, where you will feed your data and it will cluster it for you and it will give you result. So you should be able to interpret the results, you should be able to look for the or the parameters which will give you performance of that particular machine learning algorithm or that particular method. So in clustering you should be able to interpret the this squared error or optimum function, sorry, objective function, squared error, how to interpret that to get the optimum number of k, or to have proper centroid, after which iteration you should be stopping. So all those points you should know. So that's the learning objective. So practicality is you should be able to interpret these numbers and these keywords, like how to interpret k. If somebody tells you that okay, my objective function for k is equal to 3 is xy, and for k is equal to 4 is yz, then which I should be selecting. So at that time you should be able to make out based on the difference in the values that where the elbow would lie and what would be the optimum number of clusters. So that's the main learning objective. So Euclidean distance is what we have been calculating from our school days, the difference between x and x coordinates and y coordinates. And when you don't have x and y coordinates at that time, you just have point A and point B. So you go like this and like this. So x square plus y square is the Manhattan distance. So you will be given formula, you don't have to remember the formula. But the name Manhattan is based on the Manhattan part of New York City, where the distances are calculated as grids. So in that way it is done. So don't worry about the formula or the difference. Whatever formula is given for distance computation or distance calculation, you have to follow that. So in question 5, if you remember, the formula was given. Yeah, so this is the formula. Difference between x coordinates, square it. Difference between y coordinates, square it and add them together. So this was the formula already given, so we used that formula to populate this table, the distance table, and that's how we got to know which data point belongs to which centroid. So don't worry about this difference, what is the difference and what is all. Formula will be given, you just have to blindly apply the formula and not make computation mistake. What is the difference between k? I have done this ray k means and hierarchical clustering already repeated so many times. So sorry Shrija, I'm not repeating it again because I must have repeated this 4 or 5 times. uh, it's the distance formula used in Pythagoras theorem. Yeah, same thing, no, the grid formula. When you have this is how, that's why even here I have made the triangle for Manhattan distance. This is the Manhattan distance. So in k-means we compute all the centroids again and again. There is pre-decided number of centroids, and in hierarchical clustering there is a stop point and start point which is already pre-decided. So these are the difference between hierarchical and k-means clustering. We decide how many clusters we want. In hierarchical clustering we stop when we start either at every data point as single cluster or all the data points as one cluster, and then we do top down, we divide into each thing, or we build up closest data points, we club together and we go up. That's the difference in hierarchical clustering and k-means clustering. I'm keeping it here for everybody's benefit. So, are there any more doubts? So, Shrija, is everything clear now? I've briefly covered the difference between k-means and hierarchical clustering. The approach to the problem is different in both. The clustering part remains the same. How do you approach to that clustering is different.
That's not clear.
Yeah? So, are there any more doubts from your side or anything to repeat? We have some water. Yeah, so if not, then we can close today's session now. Almost 8:30. Yeah. So see you all next week. This week is pretty easy. You just have to do repetitive calculations. So problem solving will be little time consuming, but not very difficult. Okay. So all the best with your assignment submissions. I have briefly even covered the problem which somebody had posted from this week's assignment that they are not able to do. Yeah, about this within cluster sum of square. So you understand what do we mean by within cluster sum of squares? So this is 39 is within cluster sum of square. Within this cluster, what is the sum of square distance? Yeah. So these are sum of square. We are squaring this and we are summing it, right? So these numbers are within distance sum of square, right? So this is the hint at most which I can give for your this week's assignment. Yeah. So this is there is no formula. This is the formula, Euclidean distance formula. There is no yeah. So let me This is the formula, Euclidean distance formula, and then we have to compute and then add it within distance sum of squares. Within the cluster, what is the sum of all the squares? Is how you are supposed to do it. Yeah.
Okay, ma'am.
Yeah. Very clear. Decipher the word, within within cluster, what is the sum of squares. So within that particular cluster, how each data point, so for c1 the points belonging to c1 you add, then point belonging to c2 you add that within cluster sum of squares. Try deciphering the words, you will get it. Not that difficult. Once you have these numbers, you can compute this within cluster sum of square also. Okay, so shall we stop today's session? Yeah. See you all next week also. Yeah. So next week we will be doing week 8. So all the best for your week 7 assignment submission, and see you all next Tuesday.